Hello, geometry students. This is Miss Moore, and this is 7-4 properties of special parallelograms. Our essential question is, what are the properties of diagonals of rectangles, rhombuses, and squares? So the first core concept here is just the definition of these three different types of parallelograms. A rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles, and a square is a parallelogram with 4 congruent sides and 4 right angles. So moving down, here are our corollaries for this section. So our rhombus corollary says that a quadrilateral is a rhombus if and only if it has 4 congruent sides. The 7-3 rectangle corollary says that a quadrilateral is a rectangle if and only if it has 4 right angles. And the square corollary states that a quadrilateral is a square if and only if it is a rhombus and a rectangle, so it has 4 congruent sides and 4 right angles. So in this Venn diagram, this shows the overlap between these three types of parallelograms. On the left, the rhombuses have 4 congruent sides. On the right, rectangles have 4 congruent angles, and squares are classified as both rhombuses and rectangles. So for example 1, it says, for any rectangle ABCD, decide whether the statement is always or sometimes true and explain your reasoning. So if I go ahead and draw a rectangle and name the sides A, B, C, D, and we know that they have 4 right angles from the definition of a rectangle. The first one says AB is equal to BC. That doesn't always have to be true because those are adjacent sides, so this would be sometimes true. And if they were, in fact, if this was a rectangle that had 2 adjacent sides that were equal, this would be a square. And then the next one says AB equals CD. So again, I'm going to sketch a rectangle. And if AB equals CD, then this would always be true for every rectangle because opposite sides are equal. In example 2, it says, classify the special quadrilateral and explain your reasoning. Okay, so this is going to be a paragraph proof. So the first thing that we are going to state is that this shape has 2 sets of parallel sides. So by definition, it is a parallelogram. So that's the first important statement that we're making. And then in a parallelogram, which we've already proven that this is, opposite sides are equal or congruent. I'm going to use the congruency sign. And since, I'm just going like kind of every reason in a different line here. So since this figure has adjacent sides, that are congruent by the transitive property, we know that all of the sides have to be equal, which would make this a rhombus. Okay, so now a couple theorems for you. The rhombus diagonals theorem says that a parallelogram is a rhombus if and only if the diagonals are perpendicular. So you can see in this diagram here that the diagonals meet at a 90-degree angle. And the rhombus opposite angles theorem states that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So if you look, this diagonal here bisects angle A and angle C, and then the same thing with the other diagonal. I'll change to blue here. This diagonal bisects angle D and angle B. All right, so in example 3, they have given us a rhombus and they're asking us to find two specific angles within this rhombus. So based on those theorems about rhombuses and their angles and what the diagonals create, we can find the measure of angle ABC and the measure of angle ACB. So I'm going to go ahead and highlight both of those angles so you can see what we're talking about. So ABC would be this entire angle right here, and highlighted in yellow, and then ACB would be this angle right here in green. Okay, so we're actually going to start with ACB, and you'll see why in a second. This one is a little bit more straightforward. So we were just told in a theorem that the diagonals of a rhombus bisect the opposite angles. So when I look at angle ACB right here, I notice that it is half of this larger angle DCB, and they gave us the other measure of ACD as 61 degrees. So we know that angle ACB also has to equal 61 degrees. So we just solved half the problem. The next one is a little bit more complicated, but that's okay. Since we know that this diagonal bisects both of those opposite angles, and those opposite angles are congruent, we know that angle 2 and angle 3 are both equal to 61 degrees as well. We know that angle 1 is 90 degrees because where the two diagonals intersect creates a perpendicular angle. That was one of the theorems that was given to us. And now we need to use that information to help us find this angle right here, okay? So if we look at this triangle, I'm going to sketch this triangle here, right? This is A, and this is D, and this is angle 1. We know that, we know angle A is 61 degrees. We know that angle 1 is 90 degrees, so we know that this last angle, which we're going to call angle 4, those three angles have to add up to 180. So when I add these up and solve, I get 151 degrees plus angle 4 has to equal 180, which means angle 4, if I subtract 151 from both sides, I end up with 29 degrees. Okay, so angle 4 has to equal 29 degrees, which means the angle that is adjacent to it also has to equal 29 degrees. And then also on the opposite diagonal, so 29 degrees, 29 degrees. So if I want to find angle ABC, I just have to add 29 plus 29. Oops. Which would equal 58 degrees. Okay, so theorem 713 says that is the rectangle diagonals theorem, and this states that a parallelogram is a rectangle if and only if its diagonals are congruent. So looking at example 4, it says, suppose you measure one angle of the window opening and it measures 90 degrees. Can you conclude that the shape of the opening is a rectangle? Explain. So the first thing I notice is that opposite sides are congruent. So if I name the corners of this, oh, is this gonna work? Oh, my pen, hold on. Okay, so A, B, C, and D. AB is congruent to CD, and BC is congruent to DA, which makes this a parallelogram by definition. And since we know that one angle equals 90 degrees, it doesn't even really matter which angle I choose. If I choose this, In a parallelogram, I know that adjacent angles are supplementary. So by that fact, I can tell that this angle, if this angle is 90 degrees, this angle would also have to be 90 degrees. If angle C was 90 degrees, then angle D would have to be, and then obviously now all four are 90 degrees, which means that there are 4 90-degree angles, which means that this has to be a rectangle. In the rectangle ABCD, AC equals 7x minus 15 and BD equals 2x plus 25. Find the lengths of the diagonals of ABCD. So from the last theorem, we were told that diagonals of a rectangle have to be equal to each other. So we're just going to set these two equations equal to each other and solve for x. So this is something you did probably like 2 years ago in algebra. So 7x minus 15 equals 2x plus 25. I'm going to add 15 to both sides. You might have a different strategy to start this. That's okay. So I have 7x equals 2x plus 40. Subtract 2x from both sides. I'm left with 5x equals 40, which means x has to equal 8. I know I'm going pretty fast through that. If you stop here and that's what you write in your answer, unfortunately, you're going to get it wrong, because it says find the lengths of the diagonal. So we need to take that value and plug it back in to one of the equations. If it was me personally, I would plug it into both and to make sure that I did my math right. So for AC here, I'll do this one first. 7 times 8 minus 15, so that would be 56 minus 15 would equal 41. I'll go ahead and change to blue. I'm going to plug it into this one now to double check. I have 2 times 8 plus 25. 2 times 8 is 16. 16 plus 25 equals 41. So I get the same value for both, which tells me I probably did my math right. All right, and example 6 says, decide whether the parallelogram ABCD with the vertices given is a rectangle, a rhombus, or a square. Give all the names that apply. So the first strategy would probably be to graph this. So I'm going to go ahead and do that. So I have -2, -3, 2, 2, 1, -2, and -3, -1. Okay. Oops, I definitely graphed one of those points wrong. I was like, this doesn't look like any of those things. Here we go. -2. Oh, +3. There we go. Okay. There we go. Okay, so I'm going to go ahead and connect these. So I think the first good strategy would be to see if it is, to see if all the side lengths are equal. Actually, you know what? I think maybe we should first figure out if it's a rectangle. Okay, so to figure out it's a rectangle, we need to decide if all of the angles are 90 degrees. And I would need to look for the slopes, or find the slopes of each of them and see if they are opposite reciprocals of each other. So I'm going to start with the slope of the line AD. And I'm going to do this like the pretty simple way. I'm not going to use an equation. I think it's pretty silly to use an equation if I can just look at a graph and count. So starting at D, I go up 1, 2, 3, 4 over 1. So the slope of AD is just 4. Now I'm going to find the slope of AB, since those are two lines intersect. And if I do that, I start at A and I go down 1, so that'd be -1, and then over to the right, 1, 2, 3, 4, -1/4. So if I look, I can tell that those two slopes are opposite reciprocals of each other, which means that this, in fact, is a right angle. I'm going to put that right angle in green. And now I'm going to do this with the other. Actually, I'm going to stop. So you could do it for all of the angles and figure out that they're all right angles and that you have a rectangle. However, we already did a proof, and I'm kind of getting an idea. I'm kind of thinking this might be a square. So what now might be a better strategy is that if I try to prove that two sides are equal to each other, so I need to use the distance formula, or I can create a right triangle. I'll go ahead and use a distance formula since I know the coordinates already. So over here on the right, I'm going to write the distance formula at the top in case you have forgotten it. So it's just a different distance between the x points or the x vertices squared and the distance between the two y vertices squared, and then the square root of that sum. So A is at, so I'm going to find AB right now. So AB would be the square root of 3 minus 2 and negative 2 minus 2 squared. So that would be the square root of 1 squared plus 4 squared, so it would be the square root of 17. So I don't need to like simplify that any farther. I'm just going to stop at the square root of 17. Now I'm going to prove, or I'm going to show the value of DC. So the line opposite of AB. And that would be the distance formula. I'm going to plug it in. So 1 minus negative 3 squared plus negative 2 minus negative 1 squared. So I end up with the square root of 4 squared plus 1 squared, which equals the square root of 17. So I just proved that this side is congruent to this side. And now I'm going to go ahead and do the same for the sides AD and BC, because I've already proven that there's one 90-degree angle, so I know it's a rectangle. Now if I prove that all the sides are congruent, then it's a rhombus, but if it has 90-degree angle and equal sides, then it has to be a square, which is kind of what I'm thinking it is. So I'm going to go ahead and find the distance between point A and point D. I'm just going to plug in those coordinates. So negative 2 minus negative 3 squared plus 3 minus negative 1 squared. So that would be 1 squared plus 4 squared, which is equal to the square root of 17. So it's also, now I've already shown that it is congruent to the other two sides, which means I'm really close to showing that this is a square. So the last one, find the distance between angle or point B and point C. And sorry, I need to see the coordinates. So it's going to be 2 minus negative 1, squared plus 2 minus negative 2 squared. You really have to watch your negatives here. So it ends up being the square root of 1 squared plus 4 squared, which equals the square root of 17. So all the sides equal the square root of 17. I know that angle A is 90 degrees, which means that the supplementary angle would also be 90 degrees, which means all 4 of these angles are 90 degrees. So this is a square. All right, so you actually don't need to do the summary if you don't want to, but it says list different ways in which you can prove a quadrilateral is a rectangle, a rhombus, and a square. So I'll go ahead and just talk about this. If you don't write it down, that's fine. So if you have a quadrilateral, to prove it's a rectangle, you would have to show that it has 4 90-degree angles. For a rhombus, you need to show that all 4 sides are congruent. And then a square would have to have both of those things. I guess also for a rectangle, you could show that the diagonals are equal. And for a rhombus, you could show that the diagonals either are perpendicular, or that the diagonals bisect the opposite angles.